Hey, hi guys, this is Akash Verma and you're watching Cafe IO. We will be talking about Kubernetes today, so stay tuned. We should start the stream in about 5 minutes from now. Till then, enjoy some music. Not sure if some music is going to be played. There are certain interesting features that has been added, so we can do that. Maybe we can also give a clap. Not sure how that is working. So we'll just start the stream in about 4 5 minutes. Just to give a sneak peek what we are going to be talking about, we will discuss container technology. We'll talk about how containers work. We'll start with Dockers, which is very foundational, and then we'll move over to Kubernetes and talk about what Kubernetes is used for, how to kind of use Kubernetes and things like that. All right, so just stay tuned. We should start the stream at 10. I'm gonna just do some testing till then and see if I'm actually streaming or not. So till then, okay, this looks fine. Now there will be some echo. So we'll wait. All right. So let's just talk a little bit about Kubernetes and why this session, right? So the intent for the session effectively is to be able to kind of share the understanding of why Kubernetes is and how to actually get started with Kubernetes, because Kubernetes is a very vast subject. It's an extremely large topic. It's a data center grade technology. And most people who either start with Kubernetes or you start with machine learning and think MLOps, they probably start with an understanding of Docker, and they'll probably try to containerize a Flask application and just run it in Kubernetes at best. But that's not where things stop. That's where actually things start. So that is something which I want to talk about and discuss more. Start a little more foundation, go a little more back into how container technology has been shaped, and talk through a couple of slides for maybe 15 20 minutes. Just give an idea about what containers is and how do they kind of work and things like that, and then probably go about it. Hey, hi, Gogi Gadgets. Thank you for joining. Uh, thank you. Hello. I'm gonna. I think you are joining from my stream for first time. Thank you for joining. So that's what we are going to be talking about today. Kubernetes and some use cases on how to get started. Right. As a topic, I would say that Kubernetes is very vast. When you if you just look at studying Kubernetes, there are a couple of exams. For example, you have a certified Kubernetes administrator, you have certified application developer, you have certified security person, and also the infrastructure side of Kubernetes is itself a challenge. So there's a lot of things. If you just think about talking about Kubernetes, you could learn. You could just get started with core concepts. Then you could probably move on to doing a little bit of networking. Then you could move to pods. Then you could do relatively just increase in complexity, right? And that's what Kubernetes is, if you just look at learning goals from Kubernetes perspective. So in core concepts, you have to learn about cluster architecture, you can learn about APIs, you can learn about services. In scheduling, you can learn about a lot of stuff, right? How do you manage schedules? How do you create selectors, scheduling events, and things like that? Then, when you go to logging and monitoring, you'll learn how to log applications and understand application lifecycle management. Kind of just understand how to do rolling wave upgrades, how to perform an OS upgrade and things like that. Tons of things in Kubernetes. Today's session is very foundational. We are just going to be talking about how to begin in Kubernetes, and slowly over the next couple of weeks and months, maybe I'm gonna keep on adding more content to the Kubernetes discussion. That's what the stream is about. So just stay tuned and let's get started. All right. So why should we use container technology, right? And this is a question which is not philosophical in nature at all. It is important to understand that why should you adopt container technologies and what is the history behind container technology, right? So that is what I'm going to be touching upon for a few seconds. Let me just adjust my camera just for a second. Okay, it's not gonna work. Never mind. So yeah, that's the first slide, and the key things that we will scan through today is A, container technologies, B, Docker, C, productionizing, right? How do we productionize containers, Kubernetes effectively? So we are gonna build towards it. All right. Some important information, very, very critical disclaimer. All that I'm talking about can be updated really, really quickly because Kubernetes itself is upgraded every couple of months. I think it follows a 3 month release cycle, so it makes life relatively difficult when you're studying something that changes that frequently. All right. So when you want to deploy your code into production, right, there's tons of options there, and then there is large team structures at play, right? There's a lot of people, there's a lot of options, there's a lot of technologies at play, right? But how do you deploy effectively to things to production, and how once you have deployed something, how do you actually standardize the deployment methodology, right? And by standardization I really mean that large companies, how do they kind of just build on to learning this, build on to understanding, pick one technology and just generically adopt it to standardize their operations. So that's where Kubernetes and container technology kind of have some roots. The first slide we are going to be talking about is hosting infrastructure and modernization with containers. And we'll see why we need to go into. So this is more for the why part, right? Now, people, some of you, if you are from the Java world, you will probably know some of these terms, but if you're not, no worries, right? So the challenges usually associated with deployments and hosting are, how do you keep your operating system updated without causing application downtime, right? So you have deployed something on Ubuntu and Ubuntu is getting updated. There's tons of runtimes issues. You got to take care of, core node version, Python version, Java version, all the dependencies that your systems have. So how do you take care of that? Second being, how do you roll back your application again without causing a downtime? And this is also a trait which Kubernetes helps to solve. We'll kind of look at that. How do you provide high availability disaster recovery without increasing a lot of complexity, right? How do you separate your jobs, right? For example, computational jobs versus database jobs, right? How do you do that? How do you, separate it? And maybe how do you actually be very efficient? The way traditional hardware works is bottoms up, right? Not that bottoms up, but yeah. So the server hardware, there's OS, there's some sort of a virtual machine. People for the Java world would correlate. There's an app server, and then there's some configuration in EAR or WAR file, whatever is the deployable unit. Now this makes it extremely difficult, just so that there's so many number of units, and every time you deploy, you got to stack things up, right? So this is how we started with traditional. But if you actually think about it in multiple setups, this whole guest operating system that I'll showed, right, which is this OS, right, in virtualization, this is pretty pointless, right? So if you are able to just take this layer off completely, then I think there's a lot of room to play for. So the idea would be that you apply the principle of isolation and see how we can build on top of that. So that's what our containers loosely built upon. So a typical infrastructure, and this is a diagram you'll find at all the places. You will have infrastructure, which is core, physical machine, RAM, or CPU, and all of that, right? And let's say this is a probably 15 GB RAM and 9 core CPU, just for simplicity of calculation. The virtualization layer is going to help split it, virtualize it, right? And what do we mean by virtualization? It is effectively separating the hardware and providing a hardware level virtualization, right? It kind of helps you to do more and separate your machine into smaller logical chunks at a very layman level. So if I have to break this down into three OSs, just for simplicity, I'm gonna do like, let's give 5, 3 to each of them, right? And that's fixed. that's, you're not going to change it. So if your app A needs only 2 GB, you still have given 5 GB, right? So 3 GB is wasted in a virtual machine kind of a setting where you have deployed on a virtual machine. And virtual machines are not that elastic. I mean, there's some dynamic constructs coming in there, but they are not as elastic as probably you need from an application standpoint. Please do understand, this is not a comparison which is good, which is bad. I'm not debating that containers are good versus virtual machines are bad. There are tons of use cases which containers probably wouldn't be the first preference, right? Where you need virtual machines. But the idea is purely from an application development standpoint, what's probably the best. All right. So that's the thing. But when you have a containerized application, right, this is how it works. You have infrastructure, you have host operating system, and instead of hypervisor, you have an engine, which is Docker engine. And here you have all the room to play. It's like they are all very cooperative, and they can expand very elastically depending on how you have configured your containers. And that configuration is much more easier to manage than to create a whole new virtual machine. Typically, if you think about the run times, our VM could take anywhere between maybe 2 minutes to 5 minutes. It could even be more than that, right? But when you have containers, containers can be typically spun up very fast if you have used lightweight containers. Again, this does not apply to heavy containers. Like if you use base as Ubuntu and your whole container size itself is 10 GB, then that's not a good practice. But the general tendency is that containers are lightweight and they can probably be in, let's say, maybe 30 seconds to a couple of minutes, right? VMs could be typically much more. So if you have a lot of setups to do, for example, install some things, this can go to 10, 15 minutes. And that's kind of the challenge with virtual machines, right? So to simplify this whole game, what am I talking about, right? So when you have a traditional OS, this is how it works. You have the machine, this is the server. This is the, what the software needs to run. Maybe it needs Python, Java database, and your application uses it. Now imagine a scenario where application 1 and 2 use Python 3 or 3.5 and this needs Python 3.7, right? It would be a nightmare. It cannot run with this because you will have so much variable inconsistencies, you'll have so much path inconsistencies that you'll just not be able to do it in this way. Instead, what containers would enable you to do is that you have a container Linux which has all the base stuff, and then all you need, you just package it, right? So if you need an application with Python, you package it. If you need an application with Java, you package it. If you need an application with Nginx, you package it. So you've packaged it in a way that is isolated, and the dependencies that they need go along with it. So it's like when you go on a travel, you can either stop at every, I don't know, maybe the restaurant example is not that good, but it's like packaging your own food so that you're not dependent anywhere else for anything else. That's probably a loose thought. All right. Just a quick summary. What are containers and what are virtual machines? What do they abstract effectively, right? So virtual machines abstract the OS, right? Sorry, containers abstract the OS from the application, while virtual machines abstracts the server hardware. Guys, I would want to just take a pause here and say, if some of you are watching and you have not subscribed to the channel, please do subscribe, post your questions. That would mean a lot. If I can probably share some of my experiences, that would be great. I live stream every Sunday. So please do post your questions and subscribe. All right. So what it abstracts, again, application from OS and OS from hardware, virtual machine. This is interesting. Guest environment, in a container environment, guests share the same OS kernel. But here, each guest has its own OS. Now, a good example for database and for virtual machines would be, if I want to have databases, right, which are very, very stable and powerful technologies, I don't want to have them, you know, have a database which is stateless and state management issues. Though we can do that, but that would be a good use case for virtual machines. If I want to host a tool, right, which is going to be perpetual there, and I want to apply a lot of, I know that the size is needed, I know that's fixed size, I will know it's going to run 24 by 7, then VM is going to be a better choice for that matter, right? Typical boot time, I think this is what I was trying to talk about before, seconds to minutes, but this is a very debatable number, depends on the size of the container and things like that. All right. Some terminology to probably conclude the whole container background. Image means, I like to think of containers as an ISO files, right? If any of you have used video games, right? We probably 5 years before, we used to have games and ISO files broken down. So images are ISO files. These are just packaged versions. This is what will be stored on disk. It is your built, ready to be deployed code with all dependencies, all binaries, everything packaged, right? It's the whole dabba. Now this dabba is actually ready to be used. When the dabba is ready to be used, when it is given a compute and infrastructure, it is called a container. So image is just lying, container is running, which means a container has a running instance of an image. What does an engine mean? The engine host OS process that is responsible for unpacking the image, blah, blah, blah. Pretty much means that whichever runtime you have, and I want to demystify this conversation where Docker is not the only runtime. Most of you have just studied Docker, but Docker is not the only runtime out there. There's container, there's Rocket, all sorts of container runtime engines are there. So engine is the runtime that can understand this container, what is going around, and help translate it, right, to the operating system so that whatever is expected out of container can be done. Volume is simply the storage, very simple. Volume is just the storage that the container needs for the data for the application. Registry is where you save all of your, images. Cluster is a grouping of engines utilized by orchestrator, blah, blah, blah. We'll talk about that in a little while. That's Kubernetes for us. All right, now switching over to Docker. All right, everybody has heard of Docker, but I would also want to bring up a couple of other container runtime engines just to explain the idea that I'm trying to float around, right? So Containerd is actually a very popular container runtime engine. This is cloud native foundation supported. It has its own commands, very similar to Docker. Again, all of the container technologies are similar to Docker. You can build your images using this, but Docker is the probably most popular one. You have Rocket container engine. No, not this. Yeah, okay, no, I was right. View in GitHub. Rocket is another container runtime engine. It's a pod native container engine. It's not very up to date. I think they have stopped the project, but this used to be very popular. There was another called Garden container engine. There's too many of them, and Garden is used by Pivotal, which is Cloud Foundry. So this is also a container runtime engine that can manage containers. Most of them follow the open container interface. Open container interface is the runtime, which all of them have to follow, which is what Docker supports. So sometime back, Kubernetes said, I'm not going to support Docker exclusively. We'll do OCI. This is what is OCI, which is Open Container Initiative. It is the standard which governs all the uh, container formats and runtimes, right? Docker pretty much supports this, which means any container runtime that you have in your company or you are playing with around, Docker can, Kubernetes can support. And there's tons of them. All right. Now coming back to the core summary, Docker is not the only container runtime, but most people study Docker, so we'll also talk Docker. All right, guys, if any of you have not subscribed, please subscribe to my channel. Also, please throw in your questions in the chat. They would mean a lot. And if I can share some of my knowledge, that would be great. Okay, so how do you Dockerize an application, right? Very simple. You develop your app, whatever technology, doesn't really matter. You write a Docker file, and this is Docker Compose Octopus. We'll talk about Compose, and you build and run it anywhere. Now, in good old days, Java had this flag of write once, run anywhere. Unfortunately, that was not that strong, but because you had to worry about JVM issues, you have to worry about runtime challenges, you have to worry about build systems. But Docker truly has probably taken the whole game and said build and run anywhere. If I create a Docker image on my machine and I send it to you, you'll be able to use it. Pretty simple. There's nothing big there. A simple Docker workflow. How does Docker workflow work? You have, let's say, a Docker file, and we look at a sample Docker file, how it works. We'll dissect that. There's some source code. You go through a Docker engine. This is Linux, host OS, which is my machine is Linux, let's say. Then it goes to container A. I've just built it. I've pushed into container image registry. Image registry, or Docker Hub, as it is popularly and lovingly called, is just an app store of container. So you can pick any container from Docker Hub and deploy it in your stack or in your company or wherever you want it. I've just given the link to it. There's tons of applications out there. Most of the popular ones are used by people. You can use it for collaboration too. All right. So I can publish it to Docker Hub into a private registry, and anybody can just pull it and use it in their machine. So that's simply Docker Hub. That's a workflow for you. All right. Next, we are going to be talking about how to see a Docker image, and this is where it gets interesting. Now, this is the key part, right? Whatever application you have run, please understand that Docker stack is built bottoms up, right? It's a read-only stack, and there's a very thin layer, which is the right layer on top. So the first line is actually the base for a Docker image. If you think in terms of a stack, the first line goes at the bottom, and that's how it builds it. So this is a Docker file where we are going to build Jenkins, and it says from Ubuntu 16.04, which means the base image, and base image here really implies that what is the OS on which I want to build this, right? And it can be anything. It can be a base image. It can be some, some runtime with JRE built in and things like that. Then I want to download some things, run curl something. Okay, I've downloaded something. Then I have called the tar file, right? I've just executed the tar file. Just open the file that I've downloaded. Then again, I've just downloaded run curl for getting the war file for Jenkins actually. And then I've copied all of the things inside, and I've exposed a port and then defined the entry point. What this means is that I have typically taken from the internet, downloaded couple of things, unzipped that, pushed to the container inside it, built the image, the copy command is pushing, expose the port on which Jenkins needs to run, and then define an entry point. An entry point is when the container starts, that's what is going to be initialized at that port. And that's pretty much it. That's how you get a Docker image. All right. Just a little bit more deeper into it. This is an example of how a Docker engine works, the components. On the periphery, you can interact to Docker using API or CLI. You can extend it using plugins. And in the core, it will provide you orchestration capabilities, volume management, build management, container runtime, which is containerd, networking, and distribution capabilities. In a very simple sense, if you just want to run Ubuntu in your machine, these two commands, docker pull Ubuntu and docker run -it is interactive, and name is Ubuntu interact something, and then bash, it will just run Ubuntu on your machine. It's that fast, it's that quick, right? So that's Docker engine for us. Couple of key things to understand. What are the key commands? It's very simple. If you just know what you want to do, you can just imagine that, and that's the command basically. If you want to build, you say docker build. If you want to see the images, you say docker images. If you want to do run, you say run. PS would give you PS. Stop means stop. RM would be RM. Let me just see if my Docker instance is running. I'll try to spin it up and show you some commands after this. I might not have containers, but that's okay. All right. We'll jump to that. Now we'll go to the Kubernetes part, right? Which is where we need to revisit what we discussed before. So let's just see if Docker is up and running. Just a second, I need to spin up PowerShell. This is okay. If Docker is not up, it's gonna just give you an error saying Docker runtime is not available or something like that. That should not be the case on my machine. I have just started it, but I'm not sure if it's still up or it is still in the start state. Let me. Yeah, you can see it says Docker starting. I'm not sure if it's visible. On the bottom, it says Docker starting, and now, yeah, I now have got it. So I can do Docker PS, and again, it's relatively slow today. I have no idea why. No, I don't really have the daemon running. Okay, Docker daemon is still not running. Something wrong with that. Never mind. We'll just move forward. But the commands are relatively simple. You can run them on your machine once you install Docker. How do you install this, right? This is a very common question that has been asked. So I will just give you a quick fire guide. It's very, very simple. No, you don't need to have a very fancy machine or something. A normal 8 GB machine will do it. Windows Home will do it. You need to have WSL enabled. Just go and download for Windows. Just click on Windows if you are on a Windows machine. Click on Mac if you are on a Mac machine. Double click on the installer and it will take through all of that. You can change Mac with Apple, Mac with Intel, all of that you can try to do. And the installation is relatively straightforward. You don't need to pester over it. It used to be difficult previously, but now they have simplified it much. Lovely. It's very nice. Let me see if I got it for a maybe just stroke of luck. Okay. Okay, yeah, I can at least see that. Yeah, this is how the interface looks. There is some application with there's some image which I had. There are some containers which are in stop state. This was, I don't even know what application, I've probably forgotten. And volumes, and then you can go to a lot of settings. And in settings, you can probably see some updates, which is what I have. You can also run Kubernetes, and what this means is Docker will emulate Kubernetes on your machine, which is very interesting. It will create a single node cluster. There are some experimental features which I don't have. The engine configurations, don't touch this unless you know it. Uh, it says resources advanced. You will have to go to WSL integration, and it basically means that you will need to have a WSL setup in your machine Windows, which is also very easy, and you'll be able to work seamlessly with Ubuntu. So my machine has Ubuntu Linux as WSL distro, and this interacts with it. All right. So so far I've talked a lot on Docker and containers. Now let's move forward quickly and just jump over to containers and how do we productionize them, right? The actual Kubernetes stuff. So now so far what we have seen is we have moved from a traditional deployment and the industry moved to a virtualized deployment to a containerized deployment, right? And the thing is that is this enough, right? Have we answered all the questions that we began with? The fact is not really. uh, there are certain things that we have addressed, but there are certain, most of the things have not been addressed. While we have some clarity as to how to, we can imagine that if all the containers, if they were under some sort of multiple mode, if one container can run multiple instances, and there can be some sort of a master slave on main child, parent child architecture, then it would imply that there is some kind of, cluster management happening, and you could achieve high availability disaster recovery. But can I cause my operating system updated without causing downtime? Containers can do this. Rollback and updates are relatively tricky, so probably not complete. How do you provide high availability disaster recovery without increasing complexity? Still not done. Isolation can help you separate the jobs and pack less onto less machine. Not really. So you need really a little more than isolation, and that's the principle that we need to start to understand more. Right? When you manage a software and the life cycle of it, you need to worry about scheduling. You need to worry about the life cycle and health of it. You need to worry about the upgrades to it. You need to worry about scaling, load balancing, logging monitoring, security, and these kind of constructs for it. And that is where a container runtime itself alone, engine alone, is not enough, which means Docker itself is not alone. Any of them, right? You need an orchestrator, and that's where Kubernetes comes in. Another popular orchestrator which Docker provides is Docker Swarm, right? But again, I have never used it, probably once or twice in an extreme rare scenario where Kubernetes could not be even installed. It was a very small machine and things like that. But Kubernetes is probably the framework which can run distributed systems very resiliently. It can take care of your scaling requirements, it can take care of your failover, it can take care of your deployment patterns and a lot of other parameters, right? So Kubernetes is probably the answer to a lot of the questions that we have been looking at. Couple of things to know before you start to get any more deeper into Kubernetes, right? Kubernetes does not deploy source code and does not build your application. It is not a CI/CD system. It's an enabler for it, but it is not a CI/CD system. It is not a DevOps system, right? It's not like Jenkins. You can actually host Jenkins inside Kubernetes. Kubernetes is does not provide application level services. It is not meant for it, right? It's an orchestrator. It will not give you databases. It will not give you caches. It will not give you anything which is going to help you build your application. What you need to do is, if you need them, you will have to figure out how to run those applications in a containerized mode. The good part is almost all of those are available in containerized mode. Be it Redis, be it databases, be it sidecar frameworks, tons of them, right? Kubernetes does not dictate all system, logging, monitoring, or alerting system. You can use native logging for Kubernetes. You can write your file to standard logger, dump it onto Kubernetes disks. You can use a lot of agent-based systems that are popular in the cloud native world. And when it comes to configuration management, you can use JSON, you can use YAML, whatever you are able to use with kubectl. All right, at a very high level, what is the architecture for Kubernetes? Uh, you can have, there's usually an API server, Kubernetes API server, right? And this is interacting with master. You can, API server either provides interface through or through a CLI, and the master has multiple nodes, and there is an image registry where your images sit. So these kind of are going here in a constant fashion whenever you need to deploy something, right? There's a lot of more components. For example, Kubernetes has a database called etcd, which is etcd, very popular. This is a key value store. This is what Kubernetes itself uses to manage and store information. Then you have a scheduling system where Kubernetes manages all the, it's like an engine room, right? Where it manages all of the things that it needs to work with different nodes. The master has these probably three components at a larger level, as I was talking. You have an API server, scheduler, controller, etcd. This is the etcd controller is the, KV pair. This is, exposing APIs. This is scheduler. This is controller. Controller does pretty much everything else that is not covered in here. Takes care of health management, takes care of node availability, takes care of notifying or rolling upgrades, takes care of execution basically, right? What happens inside node? Node again will need to have some way to work with containers, some way to interact with the master. So typically there's a Docker engine which is called a runtime engine. This can be anything, right? Then you have kubelet, which is what interacts with Kubernetes master. Kubeproxy, same thing. Fluentd is more of an agent for some kind of logging. This is not core Kubernetes, all right? And then everything else is pod. Pods are basically containers running inside. Theoretically, one pod can have multiple containers, but usually the practice is one container per pod in most of the cases. So whenever a new deployment has to happen, Kubernetes would typically take it from the image registry, put it inside the pod, and the pod will just expose the IP and route it through Kubernetes somehow using the networking, right? It's not a very straightforward setup, but we'll look at that probably in the next live stream when I set up a cluster from scratch. We'll try to create a whole cluster on cloud absolutely from scratch. So let's just watch out for the next session. Some of the key concepts with Kubernetes. The cluster is basically a collection of hosts, right? Which means there's multiple machines. It's available as a pool. So multiple nodes combined together are called clusters. They can technically be called a node pool first, but that's okay. Master is pretty much the controller. It's also called master plane, which is to say that this is what is the administrative function for Kubernetes. It is what controls everything. Node is a single machine in the whole cluster, in the whole setup, right? This is a single machine. Namespaces are very important concepts. We'll look at it next time. They are logical cluster management inside Kubernetes, and it's the primary way of dividing a cluster or scoping access. And pod is effectively the smallest unit that we have in Kubernetes. All right, so that's pretty much what I wanted to talk to you guys about introduction to Kubernetes. And this is just a starting session, right? In the next session, we will create Kubernetes cluster on cloud. I'll use DigitalOcean Cloud as always. And we'll just see how a cluster is created, try to deploy something in probably 30-35 minutes of time. All right. Thank you. Thank you for listening. If you have not subscribed, do subscribe. Cheers. Have a great time. Bye-bye.